Hey folks, welcome back. I'm still a fish, in case that was unclear. This time we're going to talk about multiple correlation. And eventually I will move to the next slide. Okay, so multiple correlation. Remember that for a regression, y equals beta 1 x1 plus beta 2 x2, etc., beta k xk plus a plus e. Which means that when we estimate y hat, we get beta 1 plus x1, blah, 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 blah. And the only difference is we don't have e, that residual error. And instead, we just have alpha, which is the intercept. So it's the expected level of y holding all other variables at 0. Just in case we needed a refresher on multiple correlation. Please shoot me a email, Zoom chat, whatever, if you need more scaffolding. This is one of those challenges where I'm still trying to figure out where the scaffolding should be. So anyway, the point that I'm trying to get to here is that E, or error, is the difference between our y and our y hat. This is the residual. Let me illustrate. So here I have a diagram looking at cigarette consumption per adult per day, and we've plotted that against CHD mortality per 10,000 people. Now this line, this is a regression line where we're predicting cigarette consumption and mortality. From here it's symmetric because we only have 2 variables, but anyway, that red line down the middle is our prediction, and the difference between our red line and our dot, which is our actual observed value, is the residual. So it's the discrepancy between our observation and our prediction. We following? Cool. So that means that y hat is the part of y that is rated that is related to all of the x's combined. So the multiple correlation is that correlation between y and y hat. It's the correlation between our estimated y and observed y. And we are estimating y from all the individual pieces. So this can be illustrated in this equation here, where big R, so big capital R is just is a correlation between one variable and tons of others. So the total variance explained. It's R squared, but not squared. So yeah. So we can even square the value we get, and that will give us the squared multiple correlation, the SMC, which will tell us the proportion of y that is explained by all the x's. So, and here's the important piece, if y is our concept or criterion that we're trying to measure, and the x's are the items of a test, are we seeing where this is going? Well, what do? Because we're really close, right? Well, so we have the same problem. If we can't measure our concept directly, then we can't apply a regression equation to establish those optimal weights by just adding the items up. So then we can't reduce the number of patterns using our correlation because we can't measure it and measure that concept directly. If only there were a way to handle this. I don't know if my pensive face is showing up as a fish. You'll have to use your imagination. Well, spoilers, ladies and gentlemen. There is a way to do it. And we are about to learn it in the next video. So I'll see you then. Bye!